Hello everyone, welcome to today's podcast. Today we'll be discussing on a very interesting topic with explainable AI. So it's called counterfactual methods. Let's do a quick introduction on that.
Yeah, sure. So today we are going to switch our gears from all these days we are discussing on transformers, LLMs, right? Now it's time to take a step back uh, to understand why we are doing all these predictions, right? So that's what explainable AI is all about, to understand the prediction made by the model. So in explainable AI, there are various techniques to understand the model's prediction. One such is counterfactual. Right? Um, yeah. So, have you used any explainable AI tools, Chandni?
Yeah, for NLP, right, I have used this tool called Lit Language Interpretability Tool. So it's mostly like based upon the attention, it would trace back from where it is actually bringing up that result.
Yeah, that's a cool tool. So, using gradients, you are somewhat tracking back, right? So that you are using gradient as an interpretability tool here, basically. So counterfactual, on the other hand, it's completely different. So it questions. It's kind of an what if tool, if you may, right?
Hmm.
So do you know what if tool is?
Absolutely no.
Oh,
Even before going into that, what is actually a counterfactual? Just in the general English vocabulary, right?
sure.
What does it actually mean?
So have you watched Avengers?
Yeah.
In that, in the first Avengers part, so Doctor Strange used to visualize like the multiple scenarios on which
Hmm.
Avengers could end,
Yeah.
right?
Yeah.
So that's exactly what counterfactual is. So just imagine Doctor Strange is nothing but your model,
Hmm.
right? And your model is trained on a training data set, and those are nothing but facts, right? For a given feature, this is the label.
Right.
Just consider the supervised scenario here, right? Supervised training scenario. Now, in this case, just let's consider a simple loan application data set. A person of age 25 from uh, salary of greater than $300,000,
Hmm.
um, and let's add few more features. Can you help me here? Like in a
Maybe their credit score,
credit score of
their
800 or more
history
than,
of
yeah. So
shopping.
with this, you have a label saying the loan application has been credited. Let it be one,
Yeah.
right? Now for the same set of records, what
Hmm.
are the minimal changes you can do to the feature in order to make this person a loan default?
You
Does it make
mean
sense?
Lona zero?
Zero. Yeah.
Okay.
So that's the goal of counterfactual. It keeps on querying your model by perturbing the features until it gets the label flipped.
Hmm.
So it starts with the factual example. That's
Okay.
nothing but your training data or your test data.
Mm-hmm.
It should have the label basically, right? And it keeps on querying the features. It keeps on querying the model with the given features,
Hmm.
and it will make slight changes to the features.
Okay.
At one point, your model might flip the prediction, right? Do you agree? If you keep changing the
Hmm. Hmm.
input,
Hmm.
right, there is a chance that your model will flip at some point. Counterfactual algorithms are are that's their goal, right? They'll be just modifying the feature values so that the actual prediction is flipped. So this
Okay.
is just for binary classification scenario I just explained, right? Same applies to regression or even for multi-classification. I think that would get things complicated. If you got something out of binary classification use case, then I'll go ahead with the other use cases.
Yeah. So after we train the model, after
Hmm.
the complete training is done,
Yeah.
now we are going to apply this
Hmm.
counterfactual.
Correct.
So
So
it's
it can be up.
completely
So basically, counterfactual inputs two different parameters. One is your train model, and the other one is nothing but your train data. Something it could be a train data or anything that explains the distribution of your training data set.
all
Because
right.
the counterfactual generated will be from the same distribution, right? Getting?
Yeah, so for example, in the same loan example, right?
Hmm.
So now my loan prediction model has been trained.
Hmm.
Now, what this counterfactual model will do is
It's
it
not a
will,
model. It's a
huh?
search algorithm basically. Counterfactual.
Okay,
They are just search. You can start with a simple random search in counterfactual.
hmm,
So just take a factual training data set,
hmm,
right? With you know for this given set of feature, the label model predicted the feature as 1. We all know that. You can just query this and you'll get some prediction, right? For the same query set, for the same set of features, just you can think of yourself, right? You can just try modify each of these features randomly and try get the prediction from the model.
all right,
So counterfactual are tasked to do this internally. They will play with all these values
hmm,
based on different algorithms. So what I explained just now is nothing but random search. So there are some more complicated algorithms, right? So they I mean which are tailored to find out best counterfactuals.
all right. So I assumed counterfactual itself is a model.
Mm.
Then could we say it is just doing the permutation combination stuff?
Yeah, you see, you can even that's right. So if you compare, if you the random search in counterfactual is exactly that it does that, but
Hmm.
it's not that doing in an exhaustive manner, right?
Yeah.
It could be any one permutation or combination
Hmm.
which can be a counterfactual,
Got it.
but it can't be if you want you can make it exhaustive, but it's going to be computationally very expensive
Okay.
because if let's imagine
Yeah,
if you have 10 or 20 features.
got it. So, okay. So I understood till that we do have a banking data set
Hmm.
and the model is trained, and we have the trained data set with this feature leads to
Hmm.
label 1,
Hmm.
this leads to label 0.
Hmm.
So now we are taking a single
Hmm.
row
Hmm.
and then we are trying some intelligent way of combination so that to make the label as 0.
Yeah.
But why are we even doing this?
See, let's say I just applied for a loan application.
Yeah.
Okay. My loan application got rejected.
Hmm.
Okay. And when I go to the bank, they say that. Do you think they'll say a reason why it got rejected?
Maybe they might say some standard reasons to
Standard
convince.
reason. But what if they have a counterfactual tool?
Okay.
So I mean, I'm saying. See, I know my application got rejected. They can say it's because of credit score,
Hmm.
right? But what if can they say how my loan application when I apply the next time can be selected?
Okay.
No, I'm saying see, first my loan application got rejected.
Yeah.
Okay,
Yeah.
I now the next time when I try, I
Hmm.
want my loan application to be accepted.
Yeah.
So counterfactual will exactly say what changes I have to make.
Hmm.
Maybe I have to increase my credit score, right?
Yeah.
Maybe if the counterfactual algorithm finds that that is a explainable tool
Got
out
it.
there, right? Which is doing a
Hmm.
positive help to the society here.
Right.
Just imagine
So-
what effects it will have on churn as well, right? You know, a particular customer is churning because of so and so features with low value or something,
Yeah.
and if that feature is actually it's an actionable feature from the business end,
Hmm.
and if counterfactual algorithm suggests a change in that feature,
Yeah.
but so the business can actually act upon that feature, right?
Awesome.
So this is a real value explainable tool, and it is a local explainable technique, meaning for each record it can suggest a change.
Hmm.
So that's very powerful.
Wow.
And in addition to that, there are some traditional, prior to counterfactual, still people use tools like Sharp, Line. They are come up with feature importance, right? What feature contributed to the prediction? The percentage of the contribution of a feature to the prediction.
Hmm.
Now you can compute the same using counterfactual as well, right? You can even compute feature importance using counterfactuals.
Wow. You know, the idea which you mentioned, maybe for example, if I'm applying a loan for my startup and the bank has rejected it. So now when I go and they have a system to help the customers that if you edit these features, the output would be completely flipped, right? So from
Yeah.
0 it might go to 1.
So let's imagine in a probability scenario, right? So maybe with with 0.4 probability, the model would have given 0.4 value or 40 percentage for your application, meaning it will be rejected, right? It's close to zero,
Hmm.
not close to one. So your loan application got rejected. Now by maybe having few more experience, okay, just change the years of experience of a startup to maybe it's 2 years now. Maybe in 4 years it would have been accepted, or maybe if your team size is to close to 100, it would have been accepted. So all this change in features is a valuable feedback for you, don't you think so?
Definitely.
Yeah, that's it for. I mean, this is essentially what counterfactual is, and digging deep can actually confuse. But so let's take one bite at a time. Okay.
Awesome. So, this is really an interesting topic, and I know many people might say AI is a black box. We cannot predict what it is doing.
No.
It's just throwing some random result from the past data, right?
Hmm.
But
It is throwing random result. So are we, right? We
hmm,
do the same. If you want to come up with some prediction, what we all do, we do the same thing, right?
true, yeah. So, thank you so much for sharing these awesome insights on counterfactual methods. So, we're looking for more such, interesting topics on explainable AI.
Sure. And looks like Llama 3 is out, and there are few more interesting findings we have read, right? So let's elaborate Llama 3 tomorrow, and it's good to actually switch gears like this, right? One day we are discussing on counterfactual, the next day we are pulling back to LLMs. It's I think it's a good note. What do you think?
Definitely. So now I'm getting this, brain wave. Could we use LLM for explainable AI itself? Like, could you explain why it mentions? So, I think there should be some papers on that.
Yes, of course. So LLM itself can even create a story out of it, right? Not just prediction suggestion. I mean, not just a feature just suggestion.
Yeah.
But
So if someone is finding such papers, do mention in the comment, or maybe in the future videos we'll do a deeper dive into that.
sure, sounds good.
All right. Thank you so much.
Thank you.